Hello dudes, Axel here. Welcome to another Linux video. So, for a little while now, mostly over on my Twitter, I haven't mentioned it too much here on the YouTube channel, but I've been hyping up that I've begun a new Ryzen build, and I have indeed gotten that underway. I'm gonna give you guys a quick sneak preview. Fair warning, I don't have the case yet, which is why you're getting this video here instead of the full build video, because as you can probably tell by the title, this is not completely about my Ryzen build. We'll get to that in a moment, but here's a quick sneak peek of what I have so far. No case, but I have like everything else pretty much. Wait for it. There you go. That's the old one down there. There's the Ryzen stuff. Yay! Now I need to recenter this. Hold on. That good? Uh-oh. I shouldn't have done that. Hold on. That feels a bit too far to the left. It looks centered. Okay. So anyway, I do have the build kind of sort of done, just actually need the case. I'm waiting for the case to arrive, so I can't get to the full build video yet, but I will be doing that along with comparison benchmarks between it and my old i7-4770K system. But for now, we're going to talk about some findings that I had as I was doing the benchmarks for the new Ryzen system. I had already done a small series of them on my i7 in preparation for the Ryzen build, and I was like, okay, we'll just do some quick, simple benchmarks. There we go. Let's compare to Ryzen. So, I'm not going to talk about the gaming benchmarks at all. We'll save that for the actual build video. Stay tuned. But when I got to the render speed tests, I've been using Kdenlive as my video editing software. When I got to the render speed tests, it was interesting because, well, the numbers were very, very close. Very close. Now, the i7 was overclocked to 4 gigahertz. My Ryzen 7 1700 is not overclocked at all, so it's at a base of 3 gigahertz with double the threads and cores, of course. But the two processors had like almost the same render times in Kdenlive. So that was a bit weird. And not really sure what to make of that, really. So I was like, okay, maybe Kdenlive doesn't really play too well with a bunch of threads on the processor or something. I don't know. So that has led to this video where I'm going to be taking a look at a few different video editing software that is available for Linux. Mostly the focus for this video is Kdenlive and Blender. I'm also going to briefly talk about Lightworks and Davinci Resolve, as those are like the professional applications that are available for Linux, but I'm not going to go too much into those, but they will be mentioned later on for various reasons. So, starting off, this is also going to be a comparison not only for benchmarks, but what I am going to end up using in the future as a result of the benchmarks and other things. Spoiler alert, if you just want the answer to that, I'm going with Blender. If you want to find out why, stay tuned. I say, as though I'm going to put a cut there, but I'm probably not going to put a cut there. We're probably just going to keep going. So, with the Kdenlive tests, I have the baseline results from that. You'll get to see the results from my i7 when I get to the actual build video for my Ryzen 7 system. But, yeah, so for the Ryzen 7 1700 results with Kdenlive, each render test was done with the, okay, so Kdenlive's kind of weird. I can't, like, directly set the bit rate. I have to go with, like, a quality level, essentially. So, with Kdenlive, I've started rendering in WebM, or I had been rendering in WebM format. You can also do MP4. The settings you can choose from are very similar between those two. With WebM and MP4, the only major difference as far as what you can set is for the audio stuff. So with the audio for WebM, it's similar to how the video is, where it's like it's like 15 is the highest you can set. Well, with the slider, that's the highest it goes to. and it goes down. The lower the number, the better the quality, basically. I think that's based on like CRF or something, constant rate factor. I don't even know if I'm calling that right. I'm not super knowledgeable about this stuff. I've never had any professional video editing training or anything like that, or schooling or anything. Well, okay, I mean, technically school, but not like college level. Anyway, pretty much everything that I do with my video stuff is either self-learned or through free sources. So I do what I can. Anyway, with things set to the highest quality available by the sliders in Kdenlive and the fastest speed with all 16 threads selected, we had for a 1080p video. Now, okay, the video in question, it's a clip from the most recent Tomb Raider episode I did. It's roughly a minute long. I tried to match up the similar timing with Blender. I was a few seconds off, but a few seconds is not going to make that massive of a difference with the results here. So the footage in question was at 1440p. That's what it was recorded at. So for rendering that to 1080p in Kdenlive, it took 2 minutes and 5 seconds. When I went to Blender, well, first thing you need to understand with Blender, some of you might be watching this thinking, wait, I thought Blender was for 3D stuff. You can also do video editing in Blender. It's the video sequence editor. Actually works really nicely, kind of weird once you get used to it. We'll get more into user experience comparisons later. But with Blender, the thing with Blender's video sequence editor is that it actually does not use multiple processor threads very well. So you have to use like basically a third-party script thing. I'm sure some people are smart enough to make their own. I'm using one that's available on GitHub. It's called Pulverize. Basically, it makes Blender have multiple processes, so you can have like each thread work on one process. So that's what I did for this. Again, that is Pulverize, available on GitHub. I'll probably have a link to that in the description, so you guys can look at that. So that let me use all 16 threads of my Ryzen 7 for this purpose. So using all 16 threads with my Ryzen 7, that only took, for the 1080p render, remember Kdenlive was 2 minutes 5 seconds, Blender took 1 minute 30. So not double the speed or anything, but that's still significantly faster, because if that was a longer video, that would be a much better time shaved off from that. 35 seconds off is not massive for a short video like that, but that's a very nice percentage, because if we're comparing from the Blender time to the Kdenlive time, that's like 33% longer for the Kdenlive one. Am I doing that math right? Somebody will correct me. I'm kind of doing this off the top of my head. But yeah, so for a minute-long clip, doesn't look huge, but in the long run, that's a lot better. So going from there, with the 1440p, interestingly with Kdenlive, that took 3 seconds less, but I don't know, maybe that has something to do with the fact that the base footage was also 1440p. I don't know, but going back to Blender, the Kdenlive one for 1440p took 2 minutes and 2 seconds. Blender took 1 minute 40, so not a whole lot more time than the 1080p render, which is very nice. And then I also did 720p. I was going to do 4K, which for Kdenlive, it took 13 minutes and 24 seconds. Big bump there. And I was going to do the same with Blender, but I found out that if I'm using the Pulverize script and trying to use all 16 of my threads, each of those processes that the Pulverize script has it do uses a certain amount of RAM, and trying to do 4K rendering for 16 processes uses up more RAM than I have. So I could do a lower number of processes, but then that wouldn't match up with the rest of my results here, which I just remembered I was going to do a test with the 8 processes, because when you do the Pulverize script, it says by default it does half the number of processes as your CPU has threads. So with maximum of 6. So by default, it would do 6. But since it said half the number, I was going to be like, okay, let's test 8. I forgot to do that before I started recording. I'll need to throw those in afterward to see how the times compare there. But yeah, because if I do that, then I can do 4K. And I actually did do one run of that, but I don't have the result on here because I forgot to record it accurately. But it was roughly 5 minutes for 4K for a 1-minute clip. So that's still not great, but it's there. Whereas with 1440p, it's about over 1.5 times the time. So that's not too terribly bad. Then I also did 720p. And I'm also including the Lightworks render result here for 720p, but not for the rest because with the free version of Lightworks, you can only output up to 720p and you get like no control over the output settings and whatnot. And when you have things like Blender and Kdenlive and other stuff available anyway, paying for Lightworks just does not seem worth it. I thought about potentially, like not now, but later on as we get closer to the full build video, actually doing more tests with Lightworks. But as I started using Blender more and more for this, as I said towards the beginning, I'm probably just going to stick with Blender. But anyway, for the 720p results, Kdenlive took 1:51 seconds, so not actually a huge amount of variance in the render times for the different resolutions of Kdenlive, except for 4K, which I have a theory might have something to do with RAM, since that was the issue I was running into with Blender. But anyway, Lightworks only took 44 seconds, so that was the fastest. But again, I have no control over the output settings, so who knows exactly what it did. Smacked my hand on my keyboard. I hope I didn't mess anything up by pressing buttons. Okay. Blender took 1:02 seconds. So overall, Blender is significantly faster than Kdenlive because I can make use of all 16 threads of my processor. Fantastic. Get like roughly 100% usage on all the threads when doing that, which definitely means it's working. But the speeds and the render times are not the most interesting thing here, of course. There is also to consider file size. So when I first started doing the tests and I was comparing the file size between the Kdenlive output to the Blender outputs, the Blender results turned out to be a lot smaller. Now you're going to see a bunch of stuff here. It's like, what the hell's matched bitrate mean? We'll get to that in a moment. So let's, for example, take the 1080p render from Kdenlive. That would be this one down here. Not the highlighted one, but the one down here. 1080p is 224.6 megabytes. The 1080p result from Blender, the first one, was 62. So I saw that and I was like, whoa, that's awesome! For any of you who know anything about anything to do with video stuff, your first question is probably, okay, what's the bit rate? Which is not something that I considered at first, and then I finally did check it. Let me open up media info here. So for the Kdenlive 1080p render, the bit rate is 28.4. Now for 1080p, that's pretty high on the bit rate. So if we compare that to the Blender results, again, that's 224.6 megabytes total versus 62 megabytes total. The Blender bitrate was only 8,900 overall. So that's a big difference in bitrate. So, since Blender does let me manually control the bitrate, lets me manually set it, I later redid the tests with roughly matched bitrate, or at least I set the bitrate setting to be what the bitrate said for the Kdenlive render. So as you'll see on screen, as you can see actually right here, if you're looking close enough, I'm gonna make it bigger, but you could have seen it the whole time anyway. With the matched bit rates, the 720p render was about 13.8 megabits per second on the Kdenlive render. I set it to 1300 megabits for Blender, and the render times were like a couple seconds off for everything, but I'd say that's basically within margin of error. So even increasing the bitrate, the render times were about the same. The file sizes and the actual bitrate of the outputted file is where it gets interesting. So with 720p, that's the 720p matched bitrate. That did end up doing 13.6 megabits overall, whereas if we come here and compare to the WebM Kdenlive output, because I also did an MP4 just as a test, which also did a lower bitrate than the WebM. It's like the MP4 here was 9500, whereas the WebM, that's the one that I compared to with Blender, so that's the 13.8. Like, I know those are different file formats, but, you know, so obviously there's some more variance there than we're actually seeing, than I've actually shown overall. There's another variable there that I didn't really account for, but I wanted to compare what I had been rendering to in Kdenlive versus what I'm going to render to with Blender. So yes, doing a different file format kind of adds an extra variable there, but I digress. So 13.8 megabits per second for the 720p.webm from Kdenlive compared to similar from Blender. File size a lot closer now. I can tell you that the quality definitely looks better on the 720p render than it does, or than the new 720p render than it did on the original one. So that was interesting. Then we go to the 1080p render. So once again with Kdenlive, that was 28.4 megabits per second. So I set Blender to 2800 megabits per 28 megabits per second, 2800 kilobits per second. So 28 megabits per second. I said that's what I set it to in Blender. The outputted file was a little bit smaller, 1:1, but it actually made the overall bitrate 23.8 instead of the 28 that I set it to. So I guess one way I could have gotten around that was with Blender, I'm still trying to figure out how the bitrate stuff works, but like there's a bitrate option, and then below that you have minimum and maximum. I'm assuming that the actual bitrate option is probably like target bitrate that you would see in Premiere, and then obviously you got the minimum and maximum, which are pretty self-explanatory. But I just set the what I'm going to call target bitrate. I don't know if that's actually accurate. I'm assuming it is based on the results we got here. But anyway, what it actually wound up being was 23.8 megabits per second rather than the 28. So I'm assuming the 28 was just target bitrate. That makes sense to me. So I made it a little bit smaller. Where it got more interesting was with the 1440p. So from Kdenlive, the file size for the 1440p 1 minute clip is 474.3 megabytes, sorry, at 60 megabits per second. With Blender, it's 192 megabytes for the total file size, and the bitrate, while I set the target bitrate to 60, it only actually rendered it at 25 megabits per second, and with a much smaller file size there, it also still looks just as good to me. So yeah, and like 25 megabits per second, even that's probably a little more than you need for 1440, but 60, that's way too much. So yeah, those are the results that I got for the render speeds and file size and bitrate stuff between Kdenlive and Blender. I'm sure I could, like, obviously I could just lower the CRF thing with Kdenlive for the render stuff, get lower bit rates, but not being able to manually control it like I can with Blender, that greatly leads me away from Kdenlive. Very much so. So those are the render speeds and stuff like that, and that in of itself is a pretty good reason to switch from Kdenlive to Blender. But the thing with Blender is a lot of people, like, from what I usually see, they consider the video sequence editor in Blender to be like an afterthought, just kind of thrown in at the end and whatnot. But despite that, it actually does work really well. So I'm gonna go ahead and open it up here. So as we get into Blender here, I have it set the default open to the video editing. This is the video sequence editor. Let me go ahead and open up the project I was working with here. So this is that Tomb Raider video. That's already at 1440. Okay. So this is the Tomb Raider video. And what you get is very similar to what you get with most other video editors anyway. This is not the default video editing layout. I changed things up here a little bit, made that a properties panel. This is a graph editor, which is very nice for doing keyframing and whatnot. Obviously, that's your preview. You can easily render proxies. Now, with the audio, when you drag audio in, it doesn't have the waveforms showing by default, but it's as easy as clicking a checkbox. Got the video itself here. It's a little weird because it puts the video on the bottom and then the audio above it, but it's also nice because, well, you get basically unlimited video tracks because they're just kind of there for whenever you need them rather than you needing to like make more as you need them. So I actually really like that about Blender. And you get direct control over the frames and stuff down here. So overall, it's definitely different than what you'd probably be used to with other video editors, but once you get used to it, things do kind of make sense. So like, for example, if you want to move a clip around, you don't left click and drag on it, you select it with the right mouse button, which is also kind of weird, admittedly. Left click, by the way, moves the playhead around, or the marker, whatever you want to call that. Playhead probably makes more sense because you can actually make markers with M, I believe? Yeah. For like that sort of thing. I've never really actually used markers in video editing, but I'm assuming they're very useful. Well, I shouldn't say never. Not often. Anyway. You select clips with right click, and G is how you grab. And to confirm it, you would left click. To cancel it, you can right click, which, again, different from other video editors, but once you get used to it, it's nice. It's actually really nice. To choose which part of it you're rendering, that's simply the start frame and end frame, hence why that's pretty high up. It's only by frame, though, so you don't set a time, you set a frame, but what you can also, you could probably make that a lot easier by using the markers, actually. Anyway, to help you figure out where the frames are. That's how that works. This is not meant to be a tutorial. I'm just kind of going into things, hopefully somewhat briefly. For effects and things like that, there's a lot more to it, but for example, if you want to do like color correction, that's here at the bottom under modifiers. So you don't have like an effects panel, but if you do a Shift A, you can add effect strips to add things like that. You can also control opacity and whatnot in this panel. So it's very different from other video editors. I keep saying that because that is the one thing that's going to be very true with Blender. But once you do get the hang of things, and if you've already used Blender for like the 3D modeling aspect of things and stuff, the workflow with the video sequence editor should be pretty similar. It's just obviously not 3D, it's 2D, but yeah, so with the render speeds and the control over the bitrate and stuff in mind, I am going to be using Blender for the foreseeable future for my videos. Now that I'm starting to get the hang of it, I'm really starting to like it. So yeah, I'm gonna start using Blender. Should be fun. Now, earlier, I did also mention that I was going earlier, I did also mention, sorry about that, Blender kind of broke when I closed Blender for some reason. Or OBS broke when I closed Blender. Closed Blender. Anyway, earlier I did also mention I was going to also briefly bring up Davinci Resolve because that's also available for Linux. So with Davinci Resolve, it only officially supports Red Hat Enterprise Linux and CentOS. You can get it working on other distributions though. It's actually not too hard, even like especially so on Solus here is really easy to set up. But the problems with Davinci Resolve has a nice interface, and pretty much anybody will tell you it is like the standard for color grading and whatnot. So with Linux, to get audio output, you have to use Blackmagic's hardware. Like, it doesn't support Pulse Audio or ALSA or anything like that on Linux. And when I was trying to test things out for the purposes of this video, when I tried importing a clip, which speaking of, it doesn't accept anything encoded with H.264. You have to do like DNX HD or ProRes or shit like that. I kept getting a segmentation fault, which I never get anywhere else. It only happened there. So I wanted to test Davinci Resolve a little bit because it's interesting. It's a professional level piece of software available for Linux, and it just has too many problems for it to be worth it for me to even test at this point. As much as I would like it to not be that way, but oh well. We have free and open source alternatives, and I really think Blender is one of the better choices, despite how weird it may be to start using it first if you're used to other stuff. So there are my thoughts on that. Anyway, this has been a very long video, but I had a lot of stuff I wanted to talk about for it. So hopefully coming relatively soon, I'm going to get to the proper build video. I'm going to run some more of these benchmarks, like the Blender stuff, on my old i7 system, because I haven't done that because I thought it would be a simpler process than it was. Oh well, nothing ever is going to be. So I'm going to be getting to that here shortly. Definitely in time for the full build video, because the case is supposed to arrive later this week. So stay tuned for that. Anyway, that's going to be it for this one, dudes. If you guys like this, want to see more things similar to this, make sure to like, consider subscribing. Let me know in the comments below. All that good stuff if you so choose. Till next time, this has been Axel. Thank you guys for watching, and I'll see you dudes in the next one.